I'm glad to hear it. How's life?
It's really busy, but it's okay. Glad to be talking to you. Glad that we get to do this.
The
Yeah,
pleasure's mine. My friend, I had no idea you'd written a book.
yeah, I did.
Just casually, part time. I wrap up a thesis. Was it Cambridge or Oxford? And then
Uh,
I've got time to do a book as well.
I actually did the book before my master's degree, so I wrote it during undergrad. And the backstory is that I wanted to learn more about machine learning, and so I agreed to teach this course, during my undergrad on different machine learning topics, as, as a motivation to learn all these things. And then a publisher approached me, sort of, hey, you already have these course materials. Why don't you basically repackage them and sell them as a book, which then turned out to be a lot more work than I thought it would be. I thought I could just copy paste, but yeah, it's not a few years old, so it's probably
A little bit out of date, or it's sort of got
yeah.
the principles all there.
Yeah. It's funny. Like when I wrote it, I thought the knowledge in it might be valid for like 2 years. It would be helpful. Uh, I think some elements of it basically haven't changed at all, and are like still totally valid. Some other elements, in particular, back then for time series models, LSTMs were sort of the hot thing, and that of course has totally changed, and everybody's using transformer models now. But almost everything else about neural networks stays valid. Yeah.
Do me a favor. Can you explain to me simply what a neural network is?
Yeah, it's a type of machine learning model which, underpins now like all the large AI models, all the chat GPTs of this world are neural network. The big idea is that you use matrices of weights, basically. So similar to a linear regression, just many, many, many more of them. And then you train those weights through something called a gradient descent algorithm, where basically you compute a loss. So that can be a prediction loss, like an accuracy kind of metric. And then you take the derivative of that metric, and then you gradually optimize the model over many, many steps. And this is how all major machine learning models are trained today, basically through this sort of gradient descent approach.
Why do you think that hasn't changed over the last 2 years significantly?
Um, it because it's like when people came up with it, it's actually quite funny, right? So in linear regression, you can optimize in like one calculation step, right? There's an analytical solution that you can even do in pen and paper and say this is the optimal answer, and you can actually prove that it's the optimal answer, right? Uh, with a neural network and gradient descent, that's not the case, right? You just do these iterative improvement and update steps, and you can actually never prove that it's optimal. And people at one point were like, oh, it's going to go into like a local optimum, and you need to do like 50 different runs to see if you catch the optimal solution and things like that. I think it just sort of turned out to be a very flexible solution that you can apply to many, many different types of problems. And it's the kind of solution that you can use for very large models. So neural networks are useful mostly because of their scaling properties,
Hmm.
because they can be trained on very large data sets, and the models themselves can be very large. And so there's just no really other approach that would, scale to these methods and be so flexible. It can also be used with things like reinforcement learning, where you're not predicting, some supervised outcome like a correct label, but you're just trying to take the right action, take a reward. It turns out you can differentiate that as well. And as long as you can sort of differentiate anything, you can train a neural network with that. And that means you can build these neural networks for almost anything that you have sort of data and a reward signal for.
Do you find it incredible that, at some point, given, the amount of data that we had, they didn't work, and then we went past a point, and then suddenly the models started working in these large language models started working in the way that we know and love today?
Yeah, I mean, it's kind of funny, right? Like the AI breakthrough that we see right now comes from a actually quite simple sort of model, in the sense that, some very smart people said, hey, what if we just predict the next word in a sentence, basically? And we will download all the text on the internet, and we will, like, for any given text, just predict the next word in a sentence, which means we have almost unlimited data, and then we will just make the model really, really big. And the unlock, of course, was sort of the transformer architecture to scale that. But then after the transformer paper, things have not changed maybe as much as you would have thought, sort of in terms of model architecture. It just turned out to be an architecture that scaled really, really well. And yes, it's sort of behind all the AI through breakthroughs that we have now.
Explain to me the scaling laws. Obviously, it seems like a really complex thing, and when we think about scale previously to AI, we always thought about it as the exponential, right? Is the
Mm.
scaling laws the S curve that we talk about?
So it's really interesting. Basically, I'm not sure when this was exactly, but OpenAI published this paper in, I think, 2021,
Mm.
uh, where they showed that if you take a GPT type model, and you just grow it in size, with both the size of the model and the size of the data set, uh, basically it just keeps improving, right? And it's now very hotly debated whether we have reached the limits of that scaling law. I think the consensus is that we have basically just run out of data, in the sense that, the models are trained on the entire corpus of the internet,
Hmm.
plus a number of sort of reinforcement learning environments that people have created. So that internet corpus has sort of been exhausted, and different labs have found that if you just change the model without adding more data, you don't see that same improvement. And so, OpenAI has said many times, like, we are now data constrained, and we need to find a new data source. And it seems that basically that is sort of reinforcement learning and coming up with sort of these reward signals. But this is why we had such amazing sort of improvements, between sort of GPT-3 and GPT-4, sort of, over the family of models there, because they basically had a lot of internet content still to burn through, but now they have hit the limit. But that does not mean they have hit the limit of the scaling law itself. It just means that they have hit the limit of the data set that they had.
How do you define the scaling law then?
So the scaling law in sort of simplest terms says, as you scale the model and the data set, the quality of the model improves as measured by sort of some loss function or some reward function. That's as simple as, basically, bigger model is better,
Bigger
with
model is better. That's what we
with
like to
sufficient
hear.
data.
But like in the
Yeah,
work that you do in sort of code modernization for fintechs, are the bigger models better, or are the smaller, more fine-tuned models better?
the bigger models are better.
Why? Does it
So
just understand more?
Yeah, like in code modernization and code writing in general, you need to actually reason quite often about fairly, large amounts of things, right? So, say, even if you're writing code from scratch, everybody who uses cursor would know this. You might need to understand which existing things to have in my code base that I could be using here, and I need to reason over that. You need to reason over what are all the things I want to achieve, and that might be more than one thing, right? And you need to sort of potentially trade things off, and all that kind of thing. You need to think about sort of the programming language that you have and what that makes easy and what is a good pattern there. So you need to reason over all of these things. And it turns out that, that is something that the big reasoning models are just good at. And so for sort of those bigger sort of agentic tasks, it's almost always the right idea to use the biggest reasoning model you can use. People use like Opus and Sonnet from Anthropic there, but also the GPT-5 family, with especially with a high thinking enabled, which basically just means the model expends more tokens on thinking. The only time you want to use a smaller model is when you have a more interactive workflow, right? So for instance, in Cursor, there's what they call the tap model, which just auto completes certain things. And then, of course, you want to be as fast as you type, almost so that you type and immediately get suggestions. And for that, you need to have a smaller model just to enable this user experience. And that is probably the only exception. But for these, sort of autonomously running agentic tasks, you want to have a large reasoning model.
Does the cloud provider end up playing a part in which model you choose?
Yeah, so a lot of people, when they make their sort of procurement decision, they would need to have a model that sort of conforms to their security standards, right? So
Yep.
uh, especially if you're a large enterprise. And the cloud providers will typically provide a certain set of models in a way that makes it very easy to securely integrate. So, for instance,
You have
Azure
Google,
offers
Gemini.
the OpenAI model, and Google offers the Gemini, even though Google also offers the Claude model, for instance, through Vertex AI, but they do not offer OpenAI through Vertex AI. So there's often like, oh, you can have these two, but you cannot have this one. And so that definitely does make a difference, because if you have a highly secure cloud environment and suddenly someone says, I want to hit the OpenAI API and it lives on the open internet, that's like a big no-no. You just can't do that. Yeah.
Clear. So essentially, it's almost dictated by the cloud provider that they have, whoever that strategic partner is. They sort of push. Well, in Microsoft case or Azure's case, it's the Chat GPTs of the world.
It's probably, if your cloud provider did not have a good model available to you, people might find a way to
Clear.
use the other models. But as long as there's sort of three frontier models and they have two of them, they will choose between the two that their provider has available, and they will disregard the third one, basically, right? Yeah.
Can I ask, do you ever use Mistral in your work?
I have not so far. I know other people who do.
What are the vibes? Because obviously, being European, we love our European foundational model that we've got, but we end up using Claude and OpenAI and Gemini a lot more, right?
Yeah. So this is just my personal opinion here.
Yep.
I think Mistral is not a frontier model in the sense that it could compete with the OpenAIs and Claudes of the world. That's, I think, probably even they would not dispute that, because ultimately they consume far less resources in as a company, right? And their fundraising is a lot smaller. Their teams are a lot smaller. I think their play is very much focused on people who need on-prem deployments. So that's where the open source model is very valuable. And people who, for whichever reason, need to procure a European model. So if you, for instance, imagine that you would be the French railway operator, or the German railway operator for that matter, you are actually operating national security infrastructure, right? And therefore, being dependent on a US provider is not necessarily allowed to you. So someone might come and say, like, is there a way you're not? And in this case, I think Mistral is very attractive because even though they're not a frontier model, they're also not that far behind. And you get a lot of other things for that, basically.
With when I guess enterprises are making decisions around on-prem hosting for models, do you get the frontier model performance out of that? Or is it all in cloud at the moment?
So, of the, I mean, there's really there's three frontier model providers, right?
Okay.
There's OpenAI, and OpenAI is cloud only. There's Claude, which is also cloud only, and then there's Google GCP. Google actually does offer on-prem deployments of the Gemini 2.5 Pro series through their on-prem Vertex product. And I've seen people do that, and basically Google comes with a big truck that they will park into your data center. Um, and that is probably the the only way you get a frontier model in your own data center. And alternatively, you would need to use one of the open source models which are occasionally released, and which are often at least very close to frontier. So that is the DeepSeeks of the world and the Kimmys of the world. Um, but I think also, it's actually an open question whether you want to just operate your frontier model without the help of someone else, because that also means you need to operate all the guardrails yourself, right? You need to have some sort of monitoring situation in place. You quite possibly need to do fine tuning, because if you use a DeepSeek, that might not be compatible with what you think a good guardrail is, right? And they have put their own guardrails into place. And so I think it's actually really hard to operate a frontier model sort of yourself. And if you do it's very expensive to do as well. Yeah.
Is it expensive because of not only the infrastructure required, but the technical talent?
Yeah, both. So the infrastructure is much more expensive than people think it is. GPUs are really, really expensive. Um, and what is problematic is that you quite often have spiky load. It might be that all of your employees or all of your customers are like logging in at 10 a.m. and like start typing away. And a major cloud provider can sort of buffer that because they would have so much capacity of GPUs. But if you have just your 5 GPUs, it could quite possibly be that in those peak times you're actually struggling. And so you need to over provision GPUs, which then makes it even more expensive. And then, yeah, you need to have a technology organization that can run all of this, which is hard to come by because not that many people know how to operate these things at scale. So that's definitely difficult.
I appreciate you breaking it down for us. Giannis, I wanna change tack slightly and talk about code modernization in fintechs, which is some of the work you do, day
Yeah.
to day. What has been bugging me, right, is this idea that neobanks, the kind of modern banks of the world, the Monzos, the Starlings, all of these new variants, the Revoluts of the world that we have today, have sort of jumped over the legacy banking system in Barclays, HSBC, Santander as an example. Has it really changed that much?
Yeah, I mean, all the large legacy banks are still here, right? And it's this funny. There was this article in the FT, I think a month ago or so, where they basically made the point that the neobanks have not really made a dent into the core business of the established banks. A big reason for that is that almost, or I think, yeah, none of the neobanks have a major mortgage business. And mortgages are really the key driver of your classic retail bank. A mortgage is the most biggest financial product you will probably ever buy. And so if you have a Revolut account and there's £500 in that, and you do all your international spend with that, that is immaterial to where you have your mortgage. And so I think they actually have not really been disrupted. And on the sort of digital experience side, they certainly have been pushed. So every major app the bank would have produced an app, that allows you to do online banking. And it's maybe not quite as good as a Monzo, but it's certainly good enough to satisfy the customer need. And very few customers would switch bank for like that last 10% of the app experience. So I actually think the legacy banks are in a quite good state actually there, and their stock prices have been bearing that out, right? Like all the major banks would have had really good stock price rallies in the last sort of year, for sure.
And like, look, that I think you and me both can see the fact that like these apps are being updated constantly, maybe not at the pace of a Revolut or a Monzo as an example, but it seems like there is motion in the right direction.
Yeah, every bank invests hugely in technology. They all would have technology organizations that far dwarf that of the challenger banks. You can ask the question whether they are as effective, because of course they need to deal with all these legacy systems. But there's no shortage of investment in some ways, and they've all recognized the threat, and they've all, I think, responded to that most immediate pressing need, right?
These legacy systems, though, are they just stuck full of bad code and like old code? And how do you end up modernizing that?
Well, so the first thing is that old code is not necessarily bad code, right? So this code has been successfully running often for 30 years or more, right? So many people who run these systems actually take the view of you should never modernize this because this works, right? Like why would you change this?
If it works, don't. If it's not broke, don't fix it.
Yeah, and the reason to modernize anything is basically, today it's very hard to hire COBOL talent out of school, right? Not that many people learn that anymore. So you have that people problem. You have a risk problem where, there's these massive code base, like three people know how it works. It's very critical to your business. So if those people ever leave, that's a problem. And then you have potentially a cost problem where the vendors of these mainframes, of course, can say, look, we're the only provider of this mainframe. You are dependent on it. And you would have even seen that some private equity companies go and buy like the rights to certain software, and then they go and just raise prices because they can. And so really often the motivation to modernization comes from a cost perspective where the vendor signals we're gonna 5x your price now, and then you think a lot harder about modernizing.
Do you use Gen AI when you're modernizing the code?
Yeah.
I
So
assume it's not as simple as just like vibe coding a banking system.
no, it is not. And it's actually quite a lot of different steps involved, and I think there's a real gap sort of between what the cursors and so on provide, because they're mostly geared towards sort of greenfield development, while here in legacy systems you have you first have the challenge of documentation, right? You need to say, what do we even have here? And generative AI is really good at sort of churning through all of these documents, reading all that context, and then writing something out that humans can understand of what even is happening here. Then you need to figure out how it should be in the new code. So there's a architecture step, for which LLMs are also very good at sort of comparing sort of your old ways to the new ways. And then finally, you need to write out the code. And that is probably the one that is most closest to sort of the existing tooling. But you will need to have a lot of test coverage, and you will need to have a lot of quality control ultimately to make sure that your system stays on the rails,
Mhm.
and you are confident in this new system that you're deploying. So that's probably almost the hardest challenge is, yeah, this massive system, but that's not new to AI as a challenge. It's something that you have as well when humans are programming this, right? How do you gain trust in a new system? Yeah.
Do you end up finding yourself leaning on the power of the LLM to help you code?
I think LLMs are these funny beasts in the sense that they're sometimes a lot better than any human can possibly be, and sometimes they're just a lot worse.
Agreed.
And for instance, if you are coming and you're writing in a programming language that you're not very familiar with, it's almost certain that the LLM knows the language better than you do, right?
Mhm.
And even if you are a very proficient programmer in a language, it's quite possible that the LLM just knows more things than you. Um, And I think that is something that is extremely powerful. On the other hand, the LLMs struggle to sort of plan at a high level, and to think, and reason and so on, even though they've made great progress there. So what I think is happening more and more is that the humans basically are taking on planning roles, and the LLM is taking on execution roles to then run these things.
Jonas, this has been an absolute pleasure. Thank you so much for the technical breakdown. Not often do we get to go fully technical, and I appreciate the time.
Yeah, sure. Sure. Great to chat. See
Looking
you.
forward to doing it again. Thanks so much.
Yeah, see you. Bye.
Ciao. That was Jonas on the show.